Welcome, everyone. My name is Rebecca. I'm so glad that you're here. I realize that this is a strange time of the year where people are experiencing a lot of kind of unusual scheduling things. Thank you for making the time to join us. Um, I am very excited to introduce you to today's speaker, Prima Roman. And so I'm going to do things a little bit differently than how I usually do things, just to reward you all for attending on the Ides of December. So here are 3 facts about Prima Roman. So number 1, she is a very experienced applied machine learning engineer. She has about a decade's worth of experience, and that's across a bunch of different sectors. So she's seen a lot of different types of applications and done data science and machine learning in a lot of different contexts. Her title, so this is the second thing, her title is at Rotational Labs is Distributed Systems Engineer. So if you ask her what that means, she probably will say that her job is to make machine learning actually work. So that's the second fact. And then third fact, she and I have the distinction of being tied for worst at company trivia night. So we have the distinction of being the worst at company trivia night. But hey, you can't be great at everything, right? So take it away, Prima.
All right. Well, thank you so much, Rebecca, for the warm introduction, and thank you all for attending today. I know this is in the middle of holiday season, so for those of you who were able to make time out of your busy schedules to attend, thank you so much. And so let's get right into it. Let's start with this. So as this quote indicates, 2023 has been a pretty difficult year in the tech industry, and for all of us as data scientists, it's somewhat of a precarious thing to kind of see what's been happening. And so what we did is we spent this year talking to fellow data scientists, and it was a tough year for many of them. And we've seen changes in this field, and we've tried to find out from them what they're doing to stay ahead of the curve, and trying to figure out like how we can best prepare for 2024. And so really this presentation is a summary of those conversations. So there's this stat that I think a number of you probably seen, and for those of you who haven't seen, it is that 87% of data science projects never make it into production. And now, while it's unrealistic to expect every single experiment to like actually make it into some kind of a working solution, but this number seems a little too high. And I think it's one of the reasons like why we're seeing some of the layoffs, which is companies are not really seeing the kind of values on their investments now. And maybe in the past that might not have been that might have been okay. They're willing to kind of like wait things out because in the not too distant past, interest rates were low. We were not seeing the kind of inflation and interest, like the kind of climate that we're in. Some companies also hired a lot, during the pandemic, because at that point, especially in the tech industry, the pandemic actually, helped generate revenues, but then those revenues have sort of fallen short. And so companies are kind of dealing with a decrease in revenues and an increase in costs. So this number is at this point, like not acceptable. And that's sort of like one of the factors that we believe is, causing some of these layoffs. And really, again, kind of talking about revenues, if you kind of think about it, a model that has not been deployed is like leaving money on the table. And so what I'm here to present is to kind of show you, what you can do to ensure that the models that you build actually get deployed so that you can help generate value for your organization. So tip number 1, take ownership of the data. So what we believe is data provenance quality and diversity are better indicators of model success in the real world than an F1 score or an RMSE. So as as data scientists, like our traditional curriculum tends to focus on these model metrics, which makes sense when you're learning a lot of advanced concepts and trying to understand like all the complexities behind machine learning algorithms. The focus is on making sure you understand what these algorithms entail. And in the curriculum itself, like you'll see that the data sets that are generally used, like the iris data set, for example, are pretty clean cut. And the reason why we have those kinds of data sets is because these concepts are pretty complicated, and you need kind of like data sets that kind of play nicely with these algorithms so that you understand the concepts. Unfortunately, in the real world, though, the data is not quite as clear cut. It's very messy, and really have to do a lot of time like really understanding this data and cleaning the data and making sure you're feeding the right data. And if you feed in garbage data, it doesn't matter how well the model performed during the development process, but when you actually deploy it, it's not going to perform as expected. So recognizing that will give you an edge, and focusing putting your focus on that. And kind of on a related note, what we've seen is that generally the work of cleaning and transforming the data has been offloaded to data engineers, which may have made sense. I mean, it kind of like that work of like working with data is kind of in the data engineer's wheelhouse. But if you, as a data scientist, don't offload that work and don't take that responsibility, there's two problems. One is that it adds a dependency that causes unnecessary delays, and delays usually means added costs. And the second problem is that if you're not taking ownership of the data, then you don't really quite understand quite the characteristics of the data, which really is what you need to have an understanding of in order to develop better models. So really making sure that you develop the domain expertise is what will help put you in the driver's seat. I guess it looks like we've had a few questions. What I'll do is I think I'll kind of go through all of this presentation, and I'll take questions at the end. So moving on to the second tip, which is be open to trying new things instead of sticking with the status quo. So what we're familiar with is batch machine learning, like traditional data science curriculums teach us how to basically use a batch of data to train a model, and often more data implies better model performance, and that tends to be true for a lot of use cases. And the problem though with batch machine learning is that once a model is trained on the entire batch of data, its parameters doesn't change. It's essentially frozen to the data at that point in time. And for use cases where there are many use cases where this is kind of like the method that you want to follow, but consider this. The problem with batch models is that as soon as they're deployed, these models start to degrade because those parameters are frozen. So kind of think about like how when you're buying a car and they say that as soon as you take it out of the parking lot, it starts to depreciate. And batch machine learning models suffer from that same problem. And if you have to retrain these models, they can be costly and error prone, especially as as you have more data that can add more costs. But alternatively, especially these days when the data landscape is changing rapidly, you want to try other machine learning models. So recently, there's been a whole new class of machine learning models kind of fall into this category of real-time machine learning. And so the idea with real-time machine learning is that they learn from one record at a time. So you don't need a whole bunch of data to accumulate. You can start making inferences right away. And they follow this predict fit paradigm, which is that these models first make an inference. Then when they get the label, they'll learn from that data. And the training is continuous. Like there's no notion of stopping training at some point, and then now you put this model in production, and then you generate inferences. The training cycle and the inference cycle is like a continuous. It's a continuous process, And as you can imagine, because of this, these models are less susceptible to drift. And if anybody's interested in like reading the literature, they're also often referred to as online and incremental learning. And so let me kind of like explain sort of like what the difference between batch batch machine learning and real-time machine learning is in the context of like actually deploying this. As you can imagine, when real-time machine learning models make inferences initially, they might not perform as well. Like some of you might be thinking, how can they actually do well because they don't know enough about the data? But the thing here is, so let's imagine like if you know the story of the tortoise and the hare, and how the hare initially runs really fast and is like way ahead of the tortoise. And so you kind of think about the tortoise as a batch machine learning model. I mean, or the hare as the batch machine learning model, and the tortoise as a real-time machine learning model. So initially, it's going to look like the batch machine learning is off to the races and really understands the data, is making really great inferences. But at some point, as you know in that story, the hare falls asleep. And meanwhile, this tortoise that's going really slowly is kind of moving and continues to move and is catching up and it beats the hare. And that's really sort of like how, a lot of these like use cases where you kind of need something that's continually learning, that's continually moving, and that's continually evolving as the data is evolving, such that it can adapt to the characteristics of data and you get better results over time. So what are real-time models best suited for? So recommender systems, for example, Netflix movie recommendations. And Netflix itself, I think at one point was retraining its models daily. And even Netflix discovered that that was also too late to kind of make these inferences. They were finding that their models were already getting stale. And so Netflix was one of the early adopters of real-time machine learning models, like recognizing that people's preferences tend to change frequently. Another use case where real-time models really shine is an anomaly detection. I mean, you don't want to wait 3 months before you find out that you had fraudulent transactions in your credit card, and you definitely want your credit card company to address these transactions as quickly as possible. It's also used for ad targeting and content personalization. Again, like your preferences change. Like I'm watching YouTube videos. At one point, I'm kind of interested in watching some kind of content, and then I kind of move on to something else. And I, oftentimes will see the recommendations kind of adapt as my my preferences change. And then weather forecasting is another example. As I live in the DC area, and oftentimes, like during the summer, it's a really sunny day, and all of a sudden in the middle of the afternoon, it rains for an hour, and then the rain disappears. And it'd be nice to know if I'm going out, if I should be carrying a rain jacket with me, right? And then real-time models have also been used to augment large language models in order to help supplement fresh data so that they generate better results. So some of you might be thinking, well, real-time machine learning might be a great solution, but what can I do if labels aren't available? So there's another class of models called reinforcement learning models. And so the idea with these kinds of models is that they learn the optimal action to take with the objective of maximizing a reward. So if you have to look at this video here, and if you see it through its entirety, what you're seeing is you kind of picture these dogs that are trying to get to this bowl here, and they're trying different ways to get to the bowl. And based on the actions that they're taking, there's like, there are optimal ways to get the bowl. There's ways that are not working out, and you kind of score, these actions to, such that you can achieve, that target outcome. And so in this case, you're really applying, policies in order to figure out like the optimal way to train these models. And so there are, some, proven and accessible approaches such as multi-armed bandits, policy gradients, Q learning, etc. And so use cases where reinforcement learning models really shine are inventory management. I mean, think about like there might be general seasonal patterns in terms of certain products that customers are interested in, but there are also many cases where there can be a spike in demand or dip in demand, and you want to be able to adapt to those conditions and make sure that you can generate as much profit as possible. It's also a great use case in marketing and advertising and recommendation systems, where you can actually use user feedback in order to do better, ad targeting and and providing recommendations, where using things like what did users click on, what did users like, and what did they share, and what did they download. And so all sorts of information that you can use that are valuable to actually provide more personalized content and products that are useful for your customers. And reinforcement learning has been used in large language models as well. I mean, one of the techniques that made ChatGPT successful was RLHF, which is reinforcement learning by human feedback, which basically took a list of questions and asked human beings to provide feedback on these to see which was effective and which was not, and that was actually used as input to these models to generate better results. So speaking of ChatGPT, tip number 3, leverage your domain expertise to beat out-of-the-box solutions like ChatGPT. So one of the reasons why ChatGPT has been successful is it has been able to leverage, let's say in the case of the English language, the structure, right? So there's a vocabulary, and through the rules of grammar, this vocabulary is organized in meaningful patterns. And with the as algorithms got more sophisticated, as we had more compute power, more resources, and the availability of a lot diverse texts of information on the internet, and it's no surprise that generally speaking, ChatGPT has been able to perform really well, and people have used it in a large number of use cases. But the problem, especially in business, like if you can't use a generalized solution for some very domain specific problems, right? It's kind of basically trying to use some kind of a broad brush technique to apply in a case where a fine tip solution is more effective. And so as an alternative to ChatGPT is this notion of using open source models and transfer learning to create domain-specific large language models. So one of the benefits of using open source models is the fact that these open source models are out there, by nature out there in the open. So they've actually gotten a lot of feedback and support from the community and contributions. And so these models tend to be a lot more better performing because you have had a lot more feedback, versus like ChatGPT, which is a proprietary solution, as well as it is a proprietary solution that doesn't have as much of the scrutiny that open source models has. And on top of that, as you're working for companies that don't have the same kind of budgets as the large tech firms, you're trying to look for optimal ways to to generate value. Using open source models actually gives you that opportunity. And so, Hugging Face is like one of the largest repositories out there, and there are others as well from which you can download these open source models and then use a technique called transfer learning to build your own large language models that are more targeted for your use case. And so the idea with transfer learning is you're basically at this point between using transfer learning and open source models, you can kind of use your general skills in data science to kind of tune the knobs of these models to achieve the outcomes that you're looking for. So let's actually talk a little bit more about what transfer learning actually is. So transfer learning is the practice of using a pre-trained model on a new machine learning task that has a lot less data. So under the hood, these large language models are deep neural networks. So you have this input layer, and then you have these a series of computations, that take place to create all these hidden layers, and then they result in this final output layer. And what you're doing with transfer learning is you're basically chopping off, one or more of these output layers, and then feeding it your own data and creating new output layers that have parameters that are actually more suited for your particular domain. And so there's a couple of advantages with that. One is that you don't actually need as much data, right? So that's again another thing. Like if you're company with not that doesn't have the budgets of the large tech firms, you really don't need access to like the same kind of data that ChatGPT was trained on. You really what you want is your data that's within like your domain that you want to kind of feed these large language models so that it's actually more responsive to the data and is more understands the characteristics of your the data in your domain. And the other advantage is that because you're feeding it your own data, you control the retraining cycles. Like you can feed it fresh data versus say if you use an out of the box solution like ChatGPT, you're kind of at the beholden to ChatGPT's release cycles because again, even though there's a structure to the English language and there's like a finite vocabulary is constantly evolving. Like the way people express in language is constantly evolving, and so you want to be kind of adapting and along the way so that you're continuing to generate value for your customers. So again, kind of wrapping up here, the advantages of transfer learning are there's no need to relearn parts of the problem space that's common to both tests. So there's no need to reinvent the wheel every single time. So you can actually generate value very quickly. And again, you don't need the usage of like all the best and brightest, the best and computational resources. So there's no need to be GPU poor. You can even just use one single beefy laptop to create your large language models. Again, the ability to train the model on a lot less data means, again, you can kind of quickly generate insights quickly. And again, because you can control the retraining cycles, the models built using transfer learning are less susceptible to drift. And then these updated models are customized to your data set, which means that you can deliver better results for your organization. All right. So tip number 4 is use agile-based approaches to build machine learning solutions. So kind of taking cue from software engineering projects, they traditionally used a waterfall approach, which did not work, and it does not work for data science either. So the idea behind waterfall is that there's a lot of time spent up front with requirements gathering, and then you spend months and months developing an application, only to find that at the end of that cycle that the customers no longer want those same features that they had initially asked for. And similarly, like what has happened with data science projects is like we'll spend like months and months trying out like these optimal experiments with the goal of like having the best performing model. But the reality is that if you kind of look at like data and like how the value of data, if you look at this particular chart here, the value that data has, again, like just like when we talked about batch machine learning, tends to depreciate very quickly. And so what you really want to do is put your data to work immediately and get feedback early and often. So that's sort of like in software engineering too, like where once it switched over to the agile form of development, the idea was just get something deployed quickly, get feedback, and based on the feedback you iterate and use the feedback to kind of make things refine and continue to do that over time, as you to generate value for your customers. So again, kind of talking about machine learning models, like you can have the best performing model, but if it's not deployed as part of an application, it is not going to generate value. So you kind of focusing on deployment is necessary in order to make sure that you're successful. And so it helps to understand some of the software engineering best practices and kind of recognizing like how can you build your model and how it works in the context of a larger system. So some of the skills that are going to be really useful is writing reusable functions for common machine learning tasks. So think about scikit-learn. Like one of the reasons why scikit-learn became one of the most popular machine learning libraries is because there's a lot of different kinds of model families out there, but it doesn't really matter which one you choose. There's these common things that you're always doing with the model, right? You're trying to fit the model. You're going to run predict to generate inferences. then you have train test split because you have to split the data into training and test data sets, and it doesn't matter really what model that you're using under the hood. There's a lot of these like functions that are being reused, and so kind of thinking in that sense, like as you're working on your projects, you'll find, especially as you start to deploy more models, think about how you can make your workflows more efficient, and it'll help you, make you more productive and help deploy more solutions to generate more value. Other skills that you can learn, are version control. So again, like using the idea like you have to iterate and evolve. You want to make sure that you're also kind of going back and forth and kind of comparing your results from before to your current results and kind of evolving. Version control helps you with that. And you also want to write tests to make sure that when you do make changes that you're not introducing any sort of errors. And then batch scripting is another thing that helps, especially with deployments. And that doesn't mean that you have to be a DevOps expert. It's just that I think learning there's some very common things that you'll do on a regular basis, and like understanding like how to use the command line will help you. And then kind of talking about agile development. So the idea here is that you want to first build an MVP application. So where rather than like focusing on the best performing model, you want to have models that perform reasonably well. And then what you want to do is just use the feedback that you get by deploying your solutions, and iterating on that application will get you better results over time. So I'm going to pause here for a second and kind of realize that I've actually kind of thrown a lot of stuff at the audience, and some of you might be thinking that here, so I have to learn, real-time machine learning. I have to learn reinforcement learning. I have to learn software engineering. And it seems like it's a lot of work, and this field is constantly changing, and there's all these new algorithms that are coming up, and you're wondering, how can you do all of that? And the reality is that actually, if you kind of take this agile based approach, what it does is that rather than trying to go too deep and trying to learn everything and kind of be really good at everything, what you're trying to do is like just run small experiments, and then go deep as necessary based on the feedback. And so it kind of really, where you develop expertise is by putting your models out there and deploying them, so that through that feedback you actually develop an intuition of how and which tool to use, rather than like getting prematurely trying to learn everything there is to know about a tool. And to give you a concrete example, and I think some of you in the audience are students from the University of Chicago, and recently we sponsored a hackathon with the University of Chicago, where some of you developed real-time machine learning applications with minimal Python experience, no prior knowledge of real-time machine learning models, and no knowledge of real-time streaming databases. And within 2 weeks, built working machine learning applications. So it really didn't take that long, and you didn't have to have expertise. And so the idea here is that all you have to do is just get started and use kind of what you learn through experience to help develop your knowledge and expertise. All right, so tip number 5, focus on solving problems, not fancy tools and algorithms. So I'm going to pause here and ask a question of the audience. Use the chat to answer, why do companies exist? All right. Anybody else want to take a stab at this question? All right. So there's obviously like a lot of good answers to this question, but I think at the underlying reason, like why do companies exist? Like they may start out, and why do they continue to exist, and why do they continue to stay in business? Is that they help solve problems, and as long as they're continuing to help solve their customers' problems, they continue to stay in business. So, a related question: why do companies hire people? Yep. So kind of similarly here, good answers. And similarly, companies hire people to help solve their problems. So the two main problems that companies are dealing with right now is a decrease in revenue and an increase in cost. So what that means is that if you think about the cost side of the equation, the fancy tool might not be the optimal solution, right? In fact, like there's a lot of companies out there that are trying to promote their tool as the solution that will solve every single problem, and the reality is that that is not true, because there are very nuanced cases, and there's many different domains, and really, at the end of the day, if you're thinking about revenue versus cost, you really want to be thinking about how can you maximize the company's return on investment. And so that means that what you really want to be doing is, even as technologists, like where we tend to focus on the tools and the algorithms, really what you want to be thinking about the end use case and figuring out what is the optimal solution there, and using your creativity and ingenuity to solve these problems. And going back to the question that we asked in the poll, which is, what percentage of companies do you think have actually deployed models into production? I would say, based on the conversations that I've had, and regardless like what you hear kind of in the media, is that I think that percentage is really low. And it is because of the fact that there's no, regardless of the promotion and the hype that's out there about all the fancy tools, the reality is that it really does take some level of like creativity and ingenuity to solve a lot of problems in machine learning. And so we haven't really scratched. We're just at the surface of like using machine learning to generate value for companies. And so my take on this is that while there might the way I see in terms of like the way the media is kind of portrayed that there's going to be a lot of automation that's going to make people lose jobs, what I've seen in practice and through my experiences in the companies that I work for is most of the solutions that I have built for my companies is actually streamlining somebody else's job, like where a lot of work right now is still very mundane and manual and time consuming. And there's those kinds of work that people do, are like really, things that machine learning can help solve. And by using machine learning, it's actually helped these other employees within the organization be more productive in their workflow. And you might, contrary to what actually happens, is that because they're now focused and are able to drive more value for the company, that actually generates more revenue for the company, that in turn actually results in companies hiring more people rather than laying off people. And the way I see it is that the only surefire way of like machines taking away people's jobs is if we let them, right? Like if we don't use our creativity and ingenuity, then that will happen for sure. And so that's where kind of thinking about putting your problem solving hat on is going to get you further. And so to me, the way I see it is that, again, like there's so much, possibilities for innovation. We can use machine learning in ways to solve new problems and even making existing problems, and also to get rid of existing problems. So what I would say is that, you know, that if you kind of use, these tips that I kind of shared with you, you'll not only survive 2024, I believe that you will thrive in 2024. And so what I like to share is some resources that you can use to help you get started. So there's a few blog posts and websites here that you can use to kind of get more familiar with real-time machine learning, reinforcement learning, large language models, and also software engineering. And if you're actually interested in building real-time models, we invite you to try the Ensign Sandbox, and it's a very safe and risk-free way to run experiments, and see what you can do. And you can create free Ensign account and learn. We have a lot of resources on Ensign U, and you can use PyEnsign to develop your own real-time machine learning solutions. And we have data sources in our data playground. And if you need help, feel free. If I haven't helped answer any questions today, you can feel free to reach out to me through email. And so with that, I will open up the floor for questions.
Thank you so much, Prima. That was really fascinating. I am so fascinated by this idea of kind of thinking about how the economy right now is impacting like kind of the data science industry and kind of the AI ML industry. And I really don't think that I've heard anybody really dive into this topic as deeply as you just did. So that was really fascinating. Thank you so much. We do have some questions. I'm going to start with one, and maybe people can continue to add questions in, and I'll just sort of read them out to you, and we can kind of take them one at a time. But if anybody out there would like to pose a question, either using the QA feature or typing their message in the chat, go ahead and do that. But so I'm thinking about this economic argument, that there's sort of going to be a change, and there is, currently a change that's happening, and it's going to drive us to build data science solutions in ways that are new for many people, and maybe uncomfortable for many people. And I appreciate you sort of easing us into that. But I'm thinking about for people who are searching for their job, like, so either they're searching for their very first job in data science, or they unfortunately lost their job in 2023. And we know that, many data scientists did lose their jobs in 2023. And it's looking like that might happen more in 2024 in January, February. So for people who are kind of in a stressed position right now, thinking about, what they're going to do next, I'm curious if you have any thoughts about like industries or sectors that you might suggest that people look into, because I think that there is sort of a little bit of a bias to look for jobs that are in the tech space, but there are lots of different types of companies, and most of them are not tech companies. So I'm curious what you think about those industries or sectors, because I'm wondering if if it's true that consumer spending is going to go down in 2024, does that mean that people should try to get jobs with the government, right? Because maybe government spending then is more stable, and consumer spending is more volatile for the next couple of years. So I'm just very curious what your thoughts are about that.
So that's a good question. In my opinion, I think there's always in general, there's so much literature, out there, okay, this is the job that you should go, for, or this is the company you should work for, and there's a lot of promotion on that sense. But I think in general, you want to cast a wide net, and you also want to kind of think about what you're interested in working on as well, because the beauty of our professions, whether it's machine learning or software engineering, every company, at this point, there's so many companies that are interested in developing machine learning solutions, right? Because we're still, again, like I said, we barely just scratched the surface on what machine learning can do. So, and even like every company needs some kind of like the ability like build software applications. So there's really, I don't, rather than targeting specific industries, I would say go out there. Maybe you might be also want to be thinking about like, especially for people who lost jobs, like maybe the big tech companies really is not where you want to be looking for, because everybody applies there, right? So you want to be thinking about like companies that maybe have had a hard time like finding people, and you might be the person who comes in, like you are the person who's actually able to help turn that smaller company and help them grow and generate revenues for them, which then makes you more valuable to them, which in turn gives you like helps you command higher salaries. And so yeah, so that my answer to that really is just, try, kind of get putting your problem solving hat on, and figuring out ways to like help yourself like land a job and just not go where everybody else is going.
Got it. Okay, I'm gonna switch over to some of our audience questions. So first question, how do you think that, so you sort of talked about the perils of like getting hypnotized or at an early phase in your career with the iris data set, and thinking that that's sort of like what you should be focusing on is the machine learning experimentation, which algorithm to pick, and not at the expense of figuring out how to, actually work with data. And then when you get to work, it turns out that the opposite is important. Like, the algorithms are really easy to experiment with, and it's sort of mostly automatable now. The hard part is kind of figuring out how to clean the data. So like, how could academic institutions or boot camps or whatever give students like a more authentic experience, so that they don't have to kind of get dropped into their first job with really no preparation about like what's going to be hard and what they're going to need to spend time on in order to preserve their position?
So I think definitely having a course on data ingestion and wrangling is a very good course for data science programs to have. And I think in general, like it would also help, like kind of like what we did with the hackathon, like where we're the focus is on like thinking about like a working solution, right? Like and thinking about like, and then kind of providing guidance on like how you can think about like use cases in the business, like there's something that you think that's out there that hasn't been solved, or like how can you kind of use like maybe just even if it's like a prototype solution, thinking about the end user application. And I will say, and so this is sort of like a plug here, but I'm also like an adjunct professor at Georgetown University, and I believe like so the kind of and we teach a data science certificate program, and where we kind of walk data scientists to the full end to end like kind of life cycle of a machine learning project, and kind of incrementally like teaching all of the different skills that you actually need to like help build a successful machine learning application. So really kind of thinking, and it has a heavy focus on data and understanding data, and how do you ingest data, and like what are the different types of data that you have, and how to use kind of software engineering techniques in machine learning. And then kind of finally get into the actual like machine learning part, and like how do you pick which model and how do you evaluate these models. So so those are all the, and then at the end like there's a final presentation where the students get to present their work. And so that's sort of like I would say is the kind of recipe to for data science programs to kind of use now in this landscape where all of these techniques are becoming increasingly important.
Excellent. Yeah, I think that like getting to work on a real project, like there's really no replacement for getting to work on a real project with like a real data set. And while we're plugging things, I'm going to put this in the chat. But this is a link to the NSYNU page that Prima has up here on the screen. So it's like a series of modules, and each module is like, I don't know, it takes like 15 or 20 minutes. But basically you're stepping through the process of sourcing and then parsing the data, kind of, so you're really focusing on just the data ingestion and engineering parts, but like from the perspective of somebody who knows that they're going to do data science on that data like down the line. So I actually think that these like little short modules could be like a great thing that academic institutions could potentially integrate in the same way that they've integrated like the UCI machine learning repository over time with the IRIS data set and stuff. Okay, next question. You spoke on the advantages of transfer learning. Are there any important potential disadvantages to keep in mind when it comes to transfer learning?
I don't think so, because I think the point of transfer learning is to enhance the performance of a pre-trained large language model, right, for your specific use case. So I think the only thing, even there again, is to consider the data set that you're using, and kind of again like using some of those basic principles, really understand your domain, understand your data, experiment often, and make sure, and then you're doing model evaluation and making sure that you're constantly, and then making sure that you have monitoring and feedback loops in place so that you can adjust. But yeah, in terms of if you have some very highly specific domain specific problems to solve, I think transfer learning is the way to go.
Excellent. And one of the things that I'm realizing is there's actually like a whole vocabulary about transfer learning and then fine tuning. And so it might be worth it, for anybody who's thinking about those kinds of things, it might be worth it to, do a little bit of reading into that, because there are some nuances, like some shades of gray in terms of what kinds of transfer learning techniques you can use. Okay, next question. Could you please provide an example of a context or scenario where a large language model would need real-time updating? Certainly that's not kind of how we're sort of being marketed LLMs, right? Like the idea of, some of these big commercial ones are, it knows all of the English language and you can kind of converse with it about anything. So what are some like scenarios where real-time updates or not having real-time updates would be a problem for a large language model? So is it about like, I guess, and then what is the trade-off then between having kind of like a fully up-to-date large language model versus the cost of keeping it up to date in terms of compute?
Yeah, I think so. There may be cases like so in the case of one of the resources that I've actually linked to is a sentiment. How you can use a large language model for a sentiment analysis task, and this was kind of taking Yelp review data. So if there are companies that are using, say, a large language model to do kind of like real time analysis on like customer reviews, that is the case where using a large language model that you need to apply transfer learning for can somewhat struggle, just because it does take some amount of time, even with transfer learning, to train these models. So if you want to try to continue to update these models in real time and feed it fresh data, it's still going to probably take some time before these models are actually adapting to some of these changes in the reviews. And so what I would really say in that case is that there are, again, like a lot of as I mentioned, like there are other solutions out there as well, where if that sort of is the problem that you run into and where there's a limitation, there are other ways to solve this problem as well.
Yeah, I think that it certainly would be like a niche scenario where you would want to update your large language model in real time. But I'm laughing a little bit because over the weekend, I was talking to somebody and they were talking about reading this New York Times article about new slang words that have come out, and talking about how people can't understand their children anymore, and so there was like a New York Times article about a like a phrase that young people are saying right now that older adults are having a really hard time understanding. And so that's kind of like the real world version of this, right? Like it actually is the cost of communication, because language is always changing. And if your children are saying, stick out your, what for the Rizzler or whatever, and you don't know what that means, the risk is that you're failing to communicate. And that's sort of a silly example, but there are certainly examples where language is always changing all the time, and the meaning of certain words is changing, and also new words are being introduced into the vocabulary. And with most of the commercial large language models, there is no way to update the vocabulary, right? Like the vocabulary is frozen into the parameters, however many billions there are. There are billions of frozen parameters. It's not very easy to add to that vocabulary, right? So it's definitely, but it's a kind of interesting. I wonder if there will be more use cases that are coming out for real-time updates to large language models. Okay, I think we have a couple more questions, so I'm going to keep going. How will the data science market look in the mid to end of 2024? Will it continue to drop? Now, I feel compelled to say that neither Prima nor I is an economist, and we're sort of talking from anecdotal experience here, but maybe with that caveat, do you have any thoughts, Prima, that you want to share?
So I can't make predictions either, but I think I would also rather than focusing on the broader what's happening in the broader economy or the broader market, is focus on yourself and focus on how you can generate value, because that you have more control over that, right? And there are cases where people have they have survived downturns in the economy, and then there are people who have lost jobs when things are really going well. So so there's, I mean, even if the odds of the market maybe tanking, let's just say that even let's say 2024 is just a continuation of 2023. These are things that you have no control over, but what you do have control over is how you develop your skills and how you kind of market yourself in the job market, regardless of what the job market looks like. And even if the odds are against you, it doesn't mean that you can't find a job. In fact, when I first came out, the job market wasn't great, and it definitely did take me some time to find a job, but I was able to find a job, and it's mainly because I just kept trying different ways to land a job, even in the tough economy. And I actually wanted to, before we take the next question, wanted to go back to what you were talking about, the large language models and the potential need for updating large language models in real time. And there also, I kind of want to take a different take on it, which is, I think we kind of sometimes let the perfect be the enemy of the good. So it is possible that the models get things wrong, and it's only bad if it becomes drastically, it's the degradation is so drastic that it causes some real problems. But think about even as good as, let's say, maybe Netflix has gotten in recommending movies, it doesn't always get it right. Even Amazon, which was touted back when Amazon became really good because of its book recommendations. Think about how many times you go on Amazon, you bought something, and then later on it still recommends that you buy the same product, and shouldn't know that you just bought that product. And so there are a lot of use cases where this doesn't even matter, right? You may have some misses, but it's okay, as long as you're actually at least getting it right most of the time, or even more than say never, right? So even that might actually get you further than not even having a solution in place at all.
Good point. Yeah, good point. All right, we've got a couple more minutes, so I'm going to try to do one more question here. All right, hello. I am interested in learning how to build my own generative large language model, specifically to respond to prompts in certain problem contexts. And I want to use transfer learning on my own text data and using Hugging Face models. Assuming that I am already familiar with the basics of neural networks, what are some resources and references to start experimenting and trying it out with, sort of a basic model and kind of some sample data? So any tutorials or videos or articles or books that you'd recommend?
So I think Hugging Face itself actually has a lot of resources to get started, and and then of course we also have a blog post on just kind of getting started with a sentiment analysis task, just to at least kind of get you familiar with using a large language model. But my recommendation also would be, kind of depending on your use case, so there's you can use large language models for many purposes, right? So there's sentiment analysis, there's maybe classification or text generation. And so if you kind of go through, Hugging Face's kind of tutorials, you can also look for model specific to your use case. You can do a search, and then there's going to be a number of models that are out there, and you can try out a few of them, and then out of the box to see how how well they do, and then then use your data set to kind of enhance those models. And I will say this, so because again, Hugging Face has also done a pretty decent job in their interface, in terms of how to use those models. A lot of and of course as a deep learning model, the parameters that you can pass into these models are huge. But I would just start with the basics, start with the defaults, and you can kind of, the way you write the code will be very similar to what you've done with other traditional machine learning models as well. And then as I said, first just kind of build something, and then you can kind of go deep into kind of figuring out if you're running into sort of problems, then figuring out, understanding what all of those parameters mean, and then tweaking those parameters accordingly.
That sounds like great advice. I think it's a great place to start. I think that I so agree with, your philosophy on learning, Prima. I think you're a learning by doing person. And I really think that this is a good time to be that type of data scientist. Somebody who is willing to just jump in and learn by doing, rather than, kind of being drawn to go through all of the tutorials, all of the education, all of the degree programs before feeling comfortable contributing at all, trying to kind of learn on the go. I think it's good timing for that approach. So yeah, I think any final thoughts, Prima, that you want to close us out with?
Yeah, I think that you are kind of in the driver's seat of your career, and don't let a lot of the doomsday stuff out there kind of discourage you from pursuing your dreams.
Thanks so much. And thanks to everyone out there for joining us today. We hope that you will come back and see some more of our webinars in 2024. Check out our blog posts, check out NSYNU for some free training and examples and resources, and take good care.
All right, thank you, everyone.